Here's another example of a proof we can do using these four rules. Our premises say, if J, then if K, then L. Either L or J, not L, therefore not K. You might notice that 2 and 3 look like a disjunctive syllogism right away. And indeed, that's what we're going to say, is that J is going to follow from them by a disjunctive syllogism. Then once you have J, you can go up to line 1 with J. This says if J is the case, then K implies L. This says J is the case, so we know K implies L. Now, if K implies L is the case, but L is false, then that's a case of modus tollens. Namely, we have a negative consequent that's going to yield a negative antecedent. So tilde K follows. And the justifications for this have been 2 and 3 was a disjunctive syllogism. 1 and 4 made a modus ponens, and 5 and 3 made a modus tollens. Here's another example. Main operator of the first premise is a horseshoe. The main operator of the second premise is also a horseshoe. Notice that the sentence S triple bar T occurs both times, but one time here it's negative. Tilde P, notice that that's the negation of this consequent. The conclusion is Q. Now if we look at these premises and we look for Q, you find Q is right here. And this location of Q is the consequent of a conditional. That means that Q is going to result from modus ponens. At the very end of this proof, the last line is going to be modus ponens. And the sentence on which we're going to do modus ponens is going to be tilde P horseshoe Q. And here's the tilde P. But we can't use this part, tilde P horseshoe Q, right now because it's a consequent of another statement. It's not a statement unto itself. To get it to be a statement unto itself, we would have to do modus ponens to line 1 and turn the thing in the consequent place into a statement by itself. What would be needed to do that? What would be needed would be the antecedent of line 1. Well, the antecedent of line 1 happens to be the negation of the antecedent of line 2. And there's a rule that produces a negative antecedent, namely modus tollens. P implies Q, not Q, yields not P. If only we had the negation of the consequent. Well, we do. The consequent of line 2 is P. The negation of it is here at line 3. So it's a matter of doing modus tollens first to line 2 and 3, then using that sentence, which is the antecedent of line 1, in the form called modus ponens to get tilde P horseshoe Q, and then line 3 with line 5 is modus ponens again, yields Q. And here's the justifications. 2 and 3 modus tollens, 2 and 3 modus tollens, 1 and 4 modus ponens, gets tilde P implies Q, and then 3 and 5 modus ponens again. Now, you could do this kind of a proof without even thinking as much as I did as I walked through it. That is, you could just look at 2 and 3 and say, oh, they combine, and then see where that gets you and say, oh, they combine. And that would work at this level of simplicity. But the real strategy you need to understand is how to figure out that the conclusion is going to come out of the premises somewhere. If you can get in the habit of seeing the conclusion, finding it up in the premise, and anticipating what the likelihood is of where it's going to come from, you'll have a lot more success at writing proofs than if you just go with your gut and do move after move that seems legal. Alright, here's another example. H implies that if not E, then C implies not D. Line 2 says if not D, then E. Line 3 says either E or H. And line 4 says E is false, therefore C is false. Notice that I read these differently at different times. That's a matter of choice. You can read this as saying if H, then if not E, then if C, then not D. Or you can say H implies that not E implies that C implies not D. They're just two different ways of reading the horseshoe, but they amount to exactly the same thing. Now here the conclusion is tilde C. Looking up here, I would hope you can guess anticipate, let's not call it guessing, that modus tollens is going to be the move that makes that conclusion come out at the very end of this proof. To do that, we'd have to get C implies tilde D on a line by itself. To do that, we'd have to do modus ponens to this horseshoe. To do that, we would need to use tilde E, which is available here, but you can't use it on this expression yet because this expression is a consequent of that expression. So you have to get this expression out by itself. To do that, you're going to need to have H by itself. H is available here, but it's not alone. So we have to figure out how to get H by itself. Of course, 3 and 4 will do that, because you have a disjunctive syllogism right there. So H from line 3 and 4 gives you the antecedent of line 1. Here's the consequent of line 1 as line 6. Then tilde E is used with line 6 to get the consequent of that statement. C implies tilde D. C implies tilde D, and tilde D implies E from line 2, make a hypothetical syllogism. So we can say C implies E, and then with tilde E, we can say modus tollens, line 8 and line 4, that tilde C. So here are the other justifications. First, there was the disjunctive syllogism of 3 and 4, getting H. Then 5 combined with line 1, yielded by modus ponens, the consequent of line 1. Then 4 and 6 yielded C implies not D, and this isn't the only way this proof can be done, by the way. Then 7 and 2, C implies tilde D implies E, gets you C implies E, and then modus tollens gets tilde C from 4 and 8. Another rule called addition, a very simple rule. It's a rule that lets you add. That's why it's called addition. Lets you add something. If you know that some statement P is true, then you know that that statement or whatever else you want is also going to be true. It doesn't matter what you can add. You can add a compound statement, a negative statement, a simple statement. It's always going to be valid. If you think it sounds fishy, I can understand that. Do a truth table and you'll see it's always going to be the case. As long as one part of a disjunction is true, the whole disjunction is true. Then there's the constructive dilemma, which says this. It's a conjunction of two conditional statements. P implies Q and R implies S. Now either P or R is true, either P or R, that is the disjunction of the antecedents, and the conclusion is either Q or S is true. And what is that but the disjunction of the consequence? So constructive dilemma is the toughest one of these 8 rules to memorize. But you do want to memorize them all so that you can you have them at your fingertips. A conjunction of conditionals plus the disjunction of their antecedents yields the disjunction of their consequence. Here are the rules of inference, all laid out at once. These are one-way rules, that is, they only apply, you take 2 premises or one premise and you can get to a third thing or a second thing that's new. Now we're going to talk next about rules of equivalence, which are 2-way rules that let you take one form and substitute another form for it, and vice versa. They are written using the double colon to indicate 2 expressions are equivalent to one another. That'll be part 3.